So when we were simplifying yesterday, we were making equal fractions or equal ratios. So make sure you're grabbing that before we're getting started. Not okay for you to be wasting time right now, wandering the classroom, not prepared. So we were scaling down yesterday, right? Dividing both numbers by the same number. Today we're going to work a little bit more on scaling down, but also we can scale up, right? But in order to keep them equivalent, we have to do the same thing to both numbers. So whatever we do to the top or the bottom, bless you, we have to do to the bottom or the top. So whatever we do to one, we have to do to the other. That keeps them equal, okay? It's like multiplying something by one. If I multiply something by one, we still have that something, right? It doesn't change its identity. If I divide something by one, same thing. It stays the same, right? If I have 8 pieces of pizza and I'm dividing it amongst myself, one person, I get all 8 pieces. All right, so here's an example. Lucinda mixed 6 cups of apple juice with 4 cups of cranberry juice to make apple cranberry juice. Write 3 equivalent ratios for the amount of apple juice to the amount of cranberry juice. All right, so we want apple to cranberry. So apple to cranberry was 4. Do you see where I got those numbers? Notice whatever apple is needs to come first. Whatever cranberry is needs to come second. Remember, we practiced yesterday, we could write these a number of different ways, so we could use them like this. So this isn't asking you to write these in different ways. These are asking you to write equivalent ratios. So what else is this equal to? Yesterday, we practiced dividing. So what could I divide both 6 and 4 by? Celeste? 2. So whatever I do to the top, if I divide the top by 2, I have to do the same to the bottom. So I have to divide the bottom by 2. This leaves me with the equivalent ratio of 3 cups of apple juice to how many cups of cranberry juice? 2. Now, we were just seeing that we could also multiply both numbers by the same thing. Now, if we multiplied these both by 2, we would end up here, right? What could we multiply the 3 and the 2 by? It doesn't matter when we multiply, as long as we do the same thing to both. Now, if we multiply them both by 1, we still have 3 over 2, so that doesn't give us an equivalent ratio. If we multiply them both by 2, we still have 6 over 4, so we already have that one. We need 3, so we have 1, 2. What could, just pick a number. A lot of people like 5 or 10. 25 or 18, 13. Why would I multiply by 18 or 13? Do you know your multiples of 18 and 13? I would just say 10. All right, big kids use a dot for multiplication. Right? We don't want to get confused when we add that x in there. So we're going to say 3 times 10 equals what? 30. And 2 times 10 equals 20. So these 3, 1, 2, and 3 would all be equivalent ratios. And they should all be written down with the work so that you can see how we got equivalent ratios. You will likely be asked to write equivalent ratios on your quiz, right? So for questions 1 and 2, using this picture below, write 3 equivalent ratios to describe each comparison. Soccer balls to footballs. So we're just adding on to what we did yesterday. How many soccer balls do I have? 2. To how many footballs? 6. Can I divide these to scale down? Yes, because they're both even. So what should I divide them both by? 2. So, good. So 2 divided by 2 is 1. 6 divided by 2 is 3. Make sure you're showing that. Could we do the same thing we did here and multiply by something very easy? You all should know your tens, right? So this is 10 and 30. So we have 1, 2, and 3, all equivalent. Do you understand that? Try footballs to total number of balls. Try it. Corbin. All of them. No. Simplify if you can. Multiply. The top and bottom by the same. Careful. How many footballs do you have? Oh, sorry, I thought it was like, oh, no, crazy. All right, so I'm seeing you guys have yesterday down. You wrote 6 to 8, right? There's a total of 8. Then I'm seeing a lot of you divide by 2. That's what we did yesterday, right? We simplified 3/4. It's pretty step by step. And then you don't have to pick 10, but we have been because it's easy, right? You can multiply the top and the bottom by any number. So say you want to do 5. If you did 10, it's fine. Leave it. As long as you did the same thing to the top and the bottom, it will be equivalent. Kinley, come put your phone on my desk. 3 times 5 is 15. 4 times 5 is 20. All right. So they're giving us 1 and we're just writing 2 more. So they're already giving us 16 to 12. We're just writing 2 more. What can I divide? Oh, there's 2 things. Oh, this is beautiful. If they're both even, let's start just by dividing them by 2. You're right. But won't this help us get 2 more equivalent ratios? So this is 8 and this is 6, right? And if we divide by 2 again, we get 4 and 3. So now we have 2 more equivalent ratios. We didn't even have to multiply, but you could have. We don't have to divide at all. And you'll see in number 4, we can't divide to scale down. Okay? What do you need, Alani? Not a good time, right? So 2 to 7. We can't divide 2 and 7 by something. Does that change our ratio? No, you can't divide it. So we can multiply by what? What do you want to multiply by? 2? So this is 4 and 14, right? Does that make sense? We could just multiply by 2 again. Or you could multiply these. You can go back to 2 7ths if you want and multiply them by 10. I could divide these back by 2, but I'd end up with this. And I need 2 more equivalent ratios. That would just give us 1 more. So 20 and 70. If you come up with 2 different than me, as long as you did the same thing to the top and the bottom, that's totally great. What'd you do to 5 and 30? Did you simplify first? You didn't. You just multiplied. All right. So if we multiply, what did you multiply by? Maybe 2? This could be 10 and 60. If you multiplied by 10, it would also equal 50 and 300. Do you see how I'm going from here to here? I'm multiplying by 10 to get this. Here to here, I'm multiplying by 10 to get this. So you don't, if they're asking for equivalent ratios, we could just multiply. We don't necessarily have to simplify. This one's kind of ugly though. I'd probably simplify it. What can I divide 48 and 18 by? Look at your multiplication table. Where do you see them in this? 18 and 48. They're even and divisible by 3, so they're also divisible by 6. So we could divide by 2, which would give us 24 and 9. And then we could divide by 3, which would give us 8 and 3. So those would be finding equivalent ratios, right? What can I divide the 15 and the 12 by? Do you not want to divide? No. Okay. So we could double them, right? Multiply them by 2 then. So 30 and 24. Then can't we just take this and multiply by 10? We're just adding a 0. It does not matter what you do when finding equivalent ratios as long as you do the same thing to what? Excellent, Amani. Thank you. The top and the bottom. Well done. 36 and 8 are a little bit ugly to multiply. I might just have them first. That means I'm dividing by 2. So that's 18 and 4. And then maybe I want to multiply by 10. So notice with all of these, we are writing 2 equivalent fractions to each of them. All right, we're good on page 4? All right, hustle. Eight we divided by 2, and then we multiplied those ones by 10. All right, so let's see here. We have to fill in the box. How did we get from 1 to 5? What did we multiply by? 5. So whatever we did to the top, we have to do to the bottom. So we have to multiply by 5. Good job. How did we get from 3 to 24? We multiplied by 8. So from here to here, we also have to multiply by 8. Good job. Uh-oh. How did we get from here to here? We divided by 4. Good job, Celeste. So we're going to divide 40 by 4. What's 40 divided by 4? 10. How did I got to think backwards a little bit. Careful. How did I get from here to there? Notice I have to go from here to here, right? So what did I do to the 10 to get 5? I divided by 2. So what's 18 divided by 2? Good job. The order of it matters, right? What I have to, if I'm going from here to here, I have to go from right to left up here. What do I do to the 2 to get 14? Times it by 7. So I have to times the 5 by 7. What's 5 times 7? All right, which way am I going? From right to left or left to right? I know right, so I have to go right to left. So I have to go right to left down here. What do I multiply by to the 15? Good, to get 45. If you're not sure, follow the 15 till you get to 45. That's 3 times. Good. 8 times 3 is indeed 24. All right. The ratio of the number of students to the number of chaperones is 15 to 2. All right. This might help. 15 students to 2 chaperones. We're saying it's equal to 60 students to how many chaperones do they need? Good. 15 times 4, not 4. 15 times 4 is 60. So I have to do the same thing to the 2. What's 2 times 4? 8. So we need 8 chaperones. So here we had to multiply by 4 as well. Whatever we do on the top, we have to do to the bottom.
But I said 4 chaperones.
All right. So points, 2 points for every 3 questions. Correct questions, that is. If he answered 24 questions correctly, so there's 24 questions, how many points does he get? What did I multiply the 3 by? I multiplied by 8 to get the 24. So whatever I do to the bottom, I have to do to the top. Good. So this is 16 what? Points. All right, guys, I can't stress this enough. Make sure you're showing these and showing how we got them. If Karina makes $27, you know them right this second, but will you know in a week or so when we have to take a quiz?
I will.
We'll see.
I know.
Not this Friday. $27 for every 2 hours. If she worked 36 hours, notice I'm putting the labels here to help us. So I know what's on the bottom and what's on the top. James says this is 2 times 18. So I have to multiply this by 18. Times 18.
What?
Well, 8 times 27. 8 times 7 is 56. Carry your 5. 16 plus 5 is 21. And this is 7 and a 2. So we're adding these up. 486. How much money does she get?
486 items and 26 zero.
No sense.
Well, I thought that was like working for 2 hours. It's 36 hours.
She worked for 36 hours. I mean, that's still pretty good. Like 14-ish, 13-ish an hour. All right, an 18-ounce bottle of soda. So I have 18 ounces to 216 calories. We're trying to figure out how many calories he consumes if he's drinking 6 ounces. Not times 12, you're adding. What do I do to the 18 to get 6? I have to divide it by what? 18 divided by what equals 6? 3. So I have to divide this by 3. And lucky for you, this is pretty nice. 3 into 2, 1, 6. It won't go into 2. It goes into 21 7 times. That's evenly. So you would bring the 6 down. How many times does 3 go into 6? Twice. So this is 72 calories. All right, girls to boys. So 5 girls to 3 boys. If there are, that's good numbers for you gentlemen, right? You want more competition? Okay. If there are 400 sixth graders. Oh man, this one's tricky. This one's tricky. I need a ratio of total. We're trying to find boys. So boys, there's 3 boys to how many total? How many total in this? 8. So for every 8 total, there are 3 boys. Notice I had to rewrite this because I know the total. There are 400 total. So how many boys are there? What did I do to the 8 to make 400? What is 400 divided by 8? 5 would be 40. I need another 10. So that's 50. So I multiplied by 50, right? So what am I doing to the 3? Multiplying by 50. What's 3 times 50? Very good.
What? No.
Well, what did we multiply by the total? 50. So how many girls would there be? What's 5 times 50? 250. So there's 100 more girls. So you could answer the question, how many more girls were there than boys, knowing just this ratio and the total? See how much information you can require? All right. We have to determine if these are equivalent. 1/2, we're setting it equal to 6 over 12. What did I do to make it a 6? Multiplied by 6. Is 2 times 6 equal 12?
Yeah.
Yes. So this is a yes. I'll make this check into a yes. How's that? This is tricky. Is this equivalent? 24 to 18. How would I simplify? So we could have divided these both down to 1 over 2. What could I divide by the 24 and the 18? 6. So this is indeed what? 4 over 3. So let's see if 20/15 is 4 over 3. They were telling us we have to put these both in simplest form. What can I divide these both by if they end in a 0 and a 5? 5. Is this 4 over 3? So this is a yes. Is 3/7 simplest as it can get?
Yeah.
Yes. 9 and 28. Ugh. Can I divide these? By what? I can't divide 28 by 3. So these are not equivalent. We're just going to say no. All right, let's look at 48 over 16. I can divide these both by 8. Then it equals 6 over 2. So I could have kept going, but I know 6 over 2 cannot equal 6 over 4. So we're going to say no. You can prove it this way, right? We know there's no way. This does not equal. I need to put a line through that. What can I divide the 4/10 by? 2. We can do that in our heads, right? Half of 4 is 2. Half of 10 is 5. What can I divide the 14 and the 35 by? This is 2 and 5. Do these equal each other? Yes. Can we divide these both by 12? We could probably divide them by 24 even, but let's start by dividing them by 12. So that would be 2 and 6. Can we make this equal 2 and 6? Yes, we can. So these would be a yes. I did not simplify these all the way, but you can see that it is all right. We can see that we can set them equivalent without getting to the simplest form. All right. Number 6 is yours. Page 6. You got about 25 minutes. I'm sorry, 15 minutes. 15. Get a good go at it. We'll have some time on Friday or other days to go back to work completion, but try and get as many as you can done. If you haven't finished 3, once you're done with this, go back to 3, and then you're working in Alex. But you should be working quietly, please.